There we are. Now, thank you. At this time, please mute your mics for the best sound experience. Otherwise, feedback could interfere with the information we'll be sharing with you today. So without further ado, here is Mr. Azasi. Let me get that PowerPoint up for you, Mr. Azasi. Sure. There we go. Talk about functions.
Okay, hello students. My name is Mr. Isasi, and today we'll be going over functions. Let's see here. Verbally by a sentence that describes how, the input variable is related to the output variable. Graphically, by points in a coordinate plane in which the horizontal position represents the input values and the vertical position represents the output values. Numerically, by a table or a list of ordered pairs that matches input values with output values. Algebraically, by an equation in two variables. This is the four ways that a function can be represented. If you guys have any questions while I go over this PowerPoint, please stop me and let me know. Okay, functions. The idea of a function is this: a correspondence between two sets, an input and output, such that to each element of the first set input there corresponds only one element of the second point, which is the output. The input is called the domain, and the output elements in the second set is called the range. In other words, guys, the domain is like the x value, and the range is the y value. Okay? Let's look at an example verbally. Okay, for example, okay, say that you push a button, right? That's the input, and the domain is going to be the the input, and the output is going to be the range. So for example, here say that you press on the button here, and the Mountain Dew comes out. So here guys, the input is a domain, which is a Mountain Dew, and the output comes from the soda machine, and that'll be the range. Functions specified by equations. If in an equation in two variables x and y, we get exactly one output, which is y. Values for the dependent variable. For each input, which is the x, value for the independent variable. Then the equation specifies a function. The graph of such a function is just a graph of the specific equation. Let's see here. If we get more than one output for a given input, the equation does not specify a function. Let me see. Okay, now using the vertical line test. If you guys can draw like a vertical line test on a graph, if it hits the graph twice, then it's not a function. For example, on the one to the left here, if I hit this, this is my vertical line test, right? It only hits the graph only at one point. So that means that for every x, there's only one y. You see, guys, you can do a whole bunch of lines here, and it will never hit it twice. So this is a function. On the second one, if you notice, if you do the line, the vertical line test, it's going to hit the graph here, and here, and here. So it hit it more than twice. So this is not a function. And I repeat, when you do the vertical line test, it can only hit the graph once. On the third one, this is a function. Why? Because if you do the vertical line test, it only hits the graph at this point here. Now on the fourth one, right away, this should be kind of obvious because on a circle, if you do a vertical line test, it's going to hit the graph twice. It's going to hit it here, and it's going to get it. It's going to hit it here. So for example, again, say this x value right here, say it's 2. For example, you're going to have 2 and a number here, right? Whichever it can be like 3 for y, and also here it can be 2 something. So the x values repeat. On a function, the x values cannot repeat. That's why it hits the graph twice. Later on, I'll show you some examples, guys, of what I'm talking about here. Okay. let's see here, function specified by equations. For example, y equals to x squared minus 2. Let's see, if I plug in -2, right? This is the x value, which means if I plug in the -2 here, that's my input. I'm going to plug, I'm going to plug in the -2 for every x, which is right here, right? This is my x, so I'm going to plug it in there. So then I evaluate the function. So this will be 4 minus 2, so the output is 2. So this is my input, which is -2, and this is my output, which is +2. So this is a domain, and this is my range, input and output. Function notation. The following notation is used to describe functions. The variable y will now be called f of x. Once the equation y becomes a function, then it can be called f of x. It'll be the same thing as y. This is read f of x and simply means that the y coordinate of the function corresponds to a given x value. Our previous equation, y equals to x squared minus 2, can be expressed now as f of x equals to x squared minus 2. So in other words, let me see if I can write here. In other words, here's my y, so it becomes f of x. So this equation becomes a function of f of x equals to x squared. Okay, let me do the next slide. Function evaluation. This is part of today's main topic, guys. We're going to evaluate functions, which means, consider our function here, f of x equals to x squared minus 2. What does f of -3 mean? It just means that we're going to replace the x with -3. So for every x on the function, we're going to plug in -3, which means, you see, for example, that was my x squared there. So I'm going to plug in -3 for the x's. So then we have -3 squared is 9. 9 plus 2 is 11. So this is my input, right? The -2 is my input, and my output was 11. So this is the order pair that we get from the function f of -3. These are some more examples. For example, f of 2 means, you know what? Let me see if I can get the tablet so it'll be easier to write with. Here we go. So for example, right here we have x equals 2, right? Which means I'm gonna find f of 2. So f of 2 means that I'm gonna plug in 2 for every x. You see, I'm gonna plug it in there. You see, my 2 goes in there. So then we're gonna evaluate it. So this will be 6. 6 minus 2 equals the square root of 4, and the square root of 4 equals to 2. This is my result. Now let's find when x equals to a. When x equals to a means that we're going to find f of a. F of a means that I'm going to plug in a for every x, right, on the original function. So here we're going to have 3, right? 3 times a will be 3a. 3a minus 2. So this one cannot be simplified. So the answer will just be the square root of 3a minus 2. Okay. Okay, now here's where it gets a little bit more challenging for some of the students. And if you're going to be taking, say, like upper level math, like 13, 14, 24, 12 in calculus, this is when this is very well known when you get to 13, 14, pre-cal 1, and also for calculus. So here, guys, all it means that you're going to plug in the x plus h for every x. Okay, so for example, here, here's my 3, and the x is supposed to be here, correct? From here, right? From the original function. So that means I'm going to plug in x plus h for the x. So this will be 3 times 6 will be 18. 3 times positive h will give you positive 3h, and then minus 2. So then these two can be actually combined because they're like terms. So 18 minus 2 will give us 16. So this gives us 16, the square root of 16 plus 3h. Okay, now here's where a common mistake that students might make. Students at times they want to take the 16 out with 4, but that's a no-no. Why? Because here you're adding when you add subtract, you cannot do that. If it was like this, guys, say it was something like this. Say something like 16, I mean the square root of 16h. When you're multiplying, this can be taken out as 4, because what the square root of 16 will be 4, so this would have been 4 the square root of h. And again, this is a common mistake that I see with some of the students, so please eliminate that mistake. Let me go to the next slide. Okay, now the domain of a function. For example, we have, let me go to the arrow here. We have f of x equals to the square root of 3x minus 2. What's my domain? Domain of a function. So if we put in 0 here, guys, right? If we put, if we find f of 0, it means that I'm going to plug in 0 here for the x. So here, guys, it's going to be the square root of 3 times 0 minus 2. So this becomes negative 2. And remember this, let me get my marker here. On a radical, it cannot be negative. Okay, let me see here. This cannot be negative. So the function, so this function is not defined. Why? Because this, the radical cannot be negative, which is, the square root of a number cannot be negative. That's why, so what's my domain then? Okay. Okay, let's see. Question, for what value of x is a function defined then? Okay, so here's what we're going to do. Okay, let me change to see if this continues on the next slide. If not, I'll come back to it. Okay, let me go back here. Okay, let me see. Could hey, Ruben?
Yes, sir.
Ruben, take over here.
Yes, of course.
Okay.
Okay.
Ruben, doing this slide here. Okay.
Okay. All right. So if you're looking at this function, the square root of 3x minus 2, what we want to find out is what are the x values that make this function true. And as if you see, when we put in 0 here for the value of x, we're going to get the square root of negative 2, which is going to give us a non-real number. Now, so what we want to find out is when is the function true. So we can test some values. If we would put in 1 here for x, we would have 3 times 1 is 3, and 3 minus 2 is 1, and the square root of 1 is a real number. So we know that if we have numbers larger than 0, this function will be true. And we can also test the opposite direction. If we check for a number less than 0, then we plug in negative 1 for x. And 3 times a negative 1 is going to give us a negative 3. And the negative 3 minus a 2 is going to give us a negative 5. And we know that the square root of negative 5 will also give us a non-real number. So we know that the numbers to the left of 0 will give us non-real numbers, and numbers above 0 will give us a real number. So what we want to do is
Ruben? Okay, so in order to find the domain, I'll talk for Ruben for a little bit. We want to take whatever is inside of the square root, the 3x minus 2 in this case, and we want to set that greater than or equal to 0. And what we're doing, like Ruben was saying, is we're trying to find all the values that make the square root positive, basically from 0 to infinity. So by setting it greater than or equal to 0, it's going to help us to identify those values. So if I add 2 on both sides, then we get 3x is greater than or equal to 2. And if I divide by 3, then I get x is equal to 2/3. What this is telling me here is if I plug in 2/3 for x, I'm going to have a 0 inside of the square root. So your domain is going to begin at this number. So we say 2/3. And notice that I'm using a bracket. The reason you want to use a bracket is because 2/3 is included in that domain. And if I had a number line here, and this is 0, let's say 2/3 is around here, anything to the right of 2/3 is going to be part of that domain. So we would include it to infinity. Okay. Let me see what the next slide is. So in this situation here, we would want to do the same thing. So if we have, we're trying to find the domain. So we're looking at the inside. So you want to set 1/2 x minus 4 equal to 0. And so if we add the 4 on both sides, then we're going to have 1/2 x is equal to 4. Okay. So to multiply or to solve for x, I would multiply by 2 on both sides. So I get x is equal to 8. And so what this means is, and I'm going to go ahead and work it out here. If you notice, if we let x be 8, and I put 1/2 times 8 in here, then we would have the square root of 4 minus 4, which is the square root of 0. And that's going to be 0, and that's okay. But if you put anything less, and let me say this should have been greater than or equal to. Let me go ahead and, oh no, I erased the whole thing. So let me just rewrite it again. So you want to set it greater than or equal to 0. At the 4, and then we multiplied by 2. And I just want to make sure if you multiply by a negative or divide by a negative, then you want to switch your inequality sign. Okay, so if you plug in that 8, you would have equal to 0, but anything less than 8, if you put a -7 in here, for example, then you would end up with a negative in the square root, which is what we don't want. So your domain is going to start from 8, and it's going to be everything greater than 8, so that would be infinity. Okay. And so this is 2 ways you can write it. You can write it in set notation or in interval notation. And before we do this one, well, actually, I'll do that one first, and then I'll come back to whenever you have a graph, then we can also do an example like that. So here, to find the domain, if you have a fraction, there's really 3 things you want to ask yourself. Number 1 is, does your problem have any fractions? If your problem has a fraction where the variable is in the denominator, then that means you're going to have a restriction in your domain. If you have a square root, then that also means you're going to have a restriction in your domain. And if you have a logarithm, which you will learn in chapter 3, then you're going to have some restrictions. So as soon as you see a denominator, we don't want to have a 0 in the denominator because we cannot divide by 0. Okay, so we need to exclude all the numbers that would cause us to get a 0 in the denominator. So what we want to do here is we take our denominator and we set it equal to 0. And what we're doing is we're trying to find that number that's going to give us a 0. So if we add 5 on both sides, then we get 3x is equal to 5, divide by 3. So we get x is equal to 5/3. So what this is saying is that x cannot be 5/3 because if we plug it in for x, then we're going to get a 0 down here. So my domain is going to have to be everything except for 5/3. And so one way that I like to tell my students is if you have your 5/3, let's say 5/3 is right here, it's going to be all of these numbers will be in the domain except for this one. We don't want this one here. Okay, so one way to write this is we can read it. So this side is negative infinity. So we write negative infinity all the way to 5/3. Now, we don't want 5/3, so that's why we use a parentheses, okay? And then we use this symbol that looks like a U, and that stands for union, which means that it's combining both, it's taking both answers as part of the solution. And then we're gonna go from 5/3, and now we're gonna include all these other negatives. So 5/3 to infinity. So our domain in interval notation would be this right here. In a little bit, we're gonna give you a chance to ask us questions. Before I do show you the piecewise function though, I wanted to share with you, some of you might be seeing this on your homeworks. Let me just share this file really quick. And you can zoom in on the right side of your screen. There's a little zoom in button if it's a little bit small there for you. Oops. But if you have a graph and they want to know what the domain is, can you all see the graph? Yes, okay, great. So earlier we were looking for the domain, but we only have a function. Now we have the graph, but we don't have an equation. So the domain again is all the values that are used for x that will give you an output. So to find the domain, we'll look at the x values here. Okay, and so for example, if I was to pick x equals -4, and if I go up or down, does it touch my graph? And if you guys want to say yes or no, that's cool. But I could pick any of these values here, right? And I'm not going to touch my graph at all, like never. But where is it? What x value is the first x value that's going to make me touch that graph? Anybody? Will it be -2? Or what value would it be? -1? Okay, so -1, if you notice here, if I go up from -1, it touches my graph right here. And so what that means is that my domain is going to start from -1. So I'm just going to write it up here. I know I have a place in there, but I'm going to write it over here. So -1, but now I need to decide, am I going to use a parentheses or a bracket? Okay, if you see a closed dot like this, then you want to use a bracket. If you see an open dot, then we're going to use a parentheses. So here we have a closed dot, so we're going to use a bracket. And then now, if I keep looking at these x values, this is going to go, all of these x values are touching my graph. But what about these over here? Okay, in this situation, this graph is going to keep on going forever. So if we were to extend this graph further down, then these values down here are eventually going to touch the graph down here as well. So this is going to go all the way to infinity. Okay, so that would be my domain. But notice that the whole time we just work with the x's. Now, for the range, I forget that if I erase the whole thing. But this was -1 to infinity. So for the range, now you're looking at the y values, okay? So let me write the arrow here to represent it's going forever. But notice here that my graph at this point here, which is -7, is going to touch my graph here for the y value. And all these values are also going to touch my graph. And it's going to keep going until infinity, right? Negative infinity. So my range is going to go from 7 to and you want to start, you always want to start with your smallest value first. So in this case, my smallest value is negative infinity, and then all the way to 7. Okay, so that's how you would find the domain and range given a graph. When they ask you to evaluate f of -1 and you only have a graph, remember the examples Mr. Isasi gave earlier, we actually had an equation, but now we don't have the equation. So to find out what that value is going to be, then f of -1 here, the -1 is representing x. Okay, so that means we're going to go to our graph. I'm going to go ahead and erase this. We're going to go to our graph. We're going to find -1, which is right here. Oops. F of -1, which is right here. And then that's your x value. So now you want to find your output, which is your y value. So you either go up until you touch the graph or you go down until you touch the graph. In this case, we're going to go up. And here I'm touching the graph. And now I check to see what that corresponding y value is. And that's going to be a 4. Okay. So if you want to participate, try and figure out what f of 1 is. And then just throw it in the chat if you want to try it. Okay, so here's 1, right? Okay, so some of you are saying 6. So once you find your 1, we go up. And I touch the graph here. That's the first place where I touch. And then I check to see what the value is. And you guys are correct. So we would be at 6. Okay. So let me just give you one more example on finding the domain. And let's try this one here. So again, for the domain, you're always looking at the x-axis. So the first value where the x touches is not going to be over here, right? Like these numbers are not being used. So we don't care about these numbers. But the first number is actually going to be this number, which is going to be -2. So in my domain, I'm going to have a -2. Now I have to figure out, do I use a parentheses or do I use a bracket? So for -2, I'm going to have to use a parentheses because I have this open circle. And then all of these numbers, they are being used until we get up to this number, and that's a +2. And so then here we're going to use a bracket because we have the closed dot. Okay. Now let's look at the range. Let me erase that. So let's look at the range. So the range, the smallest y value is down here, right? This y value here, which is -6. And that's part of the graph, so I use a bracket. And then all of these y values are being used because at any point it's going to touch the graph until I get to this number, which is, I can't really see, 1, 2, 3. Is that a 3? 4. I think it's a 3. So this would be -3, right? And so that's how you would find your domain. So let's do f of -1 here. So I find -1, which is right here. And so my answer for that, if I go down, will give me a -6. Okay. Any questions on those examples there? I'm going to put the PowerPoint back up and then we'll come back. I have a few more examples here, I believe, in this handout. Let me just find the PowerPoint. And we were on piecewise functions. So Ruben, let me know if you are back and your mic is working, and I will let you take over. If not, I will keep going.
Okay, can you hear me now?
Yeah, I can hear you.
Okay, all right. Let's try it one more time. All right, so So piecewise functions. So what I tell my students when we're talking about a piecewise function, you want to think of this as a function made out of different pieces, kind of like a Frankenstein type of function. So it could be made out of different parts. So if a function is made out of different parts, one of the things to always look at is where are these graphs valid? And again, you're going to be looking at the domain. And that's why we're covering domain in detail, because the domain is very, very important to understand how the graph behaves and is drawn. So graphing a piecewise function is always good to do a table, okay? So if I give you this piecewise function, if you see this 3 here, okay, even though it does not look like an equation, what this is saying is that this function is only valid at this point, at the value 3, or my input 3. Now this second one, you see it is an equation, and it's x minus 2. So that's what I did. I separated them into 2 different parts that represent this function. You're also always going to know that you're dealing with a piecewise function when you see this bracket here in correlation with the name of the function. Now, to the right of this inner piece is the domain of the function. This is telling you where this function is valid. And it says here, we'll have 3 for every value of x that is less than or equal to -1. And for this other piece of the function, x minus 2, this value is always valid if x is greater than or greater than -1. Now, again, so here, if I see that if I plug in values for x, -1, -2, -3, my output will always be 3. If it's -1, my answer is 3. If it's -2, my answer is 3. If it's -3, my answer is 3. So as an ordered pair, the x value here is -1, and again, my y value is 3. My x value is -2, my y value is 3. My x value is -3, my y value is 3. Now, if we look at the other piece of the function, and we pick different values for x, we have -1, 0, and 1. And the reason why I wanted to pick these, again, this domain is telling me where this value, this function is valid. So when I plug in -1 here, -1 minus 2 is going to give me an output of -3. Again, as an ordered pair, when my x value was -1, my y value was -3. Let's plug in 0. 0 minus 2. 0 minus 2 is just going to give me an output of -2. So when my x value was 0, my y value was -2. Now, here, again, 1 is greater than -1, so 1 minus 2 is going to give me a -1. So when my x value was 1, my y value is -1. So when we go to graphing this piecewise function, okay, the constant part of it, the 3, any value that I gave for x, my output was going to be 3. So this gives us a constant function where it's flatline. It's always the same value at 3. And if we look at the second part of this function, okay, we started here. It says that x has to be greater than -1. So as Ms. Chuka had demonstrated before, when we're starting at a particular value and not including that point, we're going to put in an open circle, okay? Excellent. And so Ms. Chuka is writing to correlate. When we're looking at inequalities, anytime that we have less than or equal or greater than or equal, because of the equals there, we know that that point could also be true. So we do a filled circle. When there's no equal, we're going to do an open circle, okay? So on this point, we have an open circle when we start at the value of -1. We're not including it, but we start at that point, and we plot these points that we found on our ordered pairs before. And this is how to evaluate the graph, okay? Any questions? Now, since we're talking about interval notation, I also like to explain it with a number line, okay? And I like to remember my students, back when they were, in maybe junior high school or maybe even elementary, when they told you, okay, I want you to give me the numbers between 1 and 3. So, and then they would tell you, okay, the numbers between 1 and 3 would be, and then they asked you to write a line on top of it. And if they told you, I want you to include the numbers between 1 and 3, they would tell you, do a filled circle, right, between this line, okay? Now, if they told you, I want to look at the numbers between 1 and 3, but not including 1 and 3, they had asked you to do open circles, okay? So again, when we are including a number, we want to fill in the circle. When we're not including the number, we want to do an open circle. And again, the filled circles are going to be referencing the equal sign or even the greater than or equal and less than or equal to. But the open circles are always going to be just for the greater than and less than symbols, okay? Any questions? All right, so let's go ahead and move forward to to a very, very important function, which is the difference quotient function. Now, for those of you who are going to move further in mathematics, you will see this later on. But the reason why we represent this particular function now is because it's good practice in evaluating functions. And if you see, it can be a little bit scary, but don't fret. The best way to approach this difference quotient function is to do it in pieces. So if you see here, to evaluate this expression, we're going to evaluate the function by plugging in our input is going to be x plus h. And then we're going to subtract it by the original function, just what the value at x is, and we're going to divide this by h. Now, this symbol here, h cannot equal 0. So again, as stated by Ms. Chuka before, we are looking at an expression that is a fraction. And when we have fractions, we never want 0 as our denominator, because that's going to give us an undefined. It's going to, if we plug it as 0 in our calculator, it's going to give us an error. So we never want a 0 on the denominator. So let's go ahead and do an example of this difference quotient function, okay? So let's say that I give you this function, negative 2x squared plus x plus 5. Find and simplify the expression. So what we'll do first is we will solve this expression by putting our input as x plus h. So everywhere we see x, we're going to plug in x plus h. So we have minus 2 parentheses x plus h squared plus x plus h plus 5. Okay, now I did skip this, but this section here, this x plus h, are two of these. Okay, we have x plus h times x plus h. That's what the square means. Okay, so in order to solve for this, we're going to do FOIL, right? This x is going to multiply with this x will multiply with this h will multiply with this x will multiply with this h. And when I do that, okay, it's going to give me x squared plus 2xh plus h squared, okay? And I still have that negative 2 outside that I need to multiply and distribute to this. Again, the x plus h, there's no exponent, it's just going to stay the same, so we just leave it alone, and again, we have the constant, the plus 5. So then now let's deal with this negative 2. We're going to distribute this negative 2 to all of the values inside this parenthesis. So negative 2 is going to multiply to the x squared, which is going to give us negative 2x squared. Negative 2 is going to be multiplied to the positive 2xh, which is going to give us a negative 4xh. And the negative 2 is going to be multiplied to the h squared, which is going to give us negative 2h squared plus x plus h plus 5. That's it. We're done. We evaluated our input as x plus h to this function. Okay. So the next step that we want to do is put it together. Okay. We want to evaluate the difference quotient function. So this is the part that we just solved by putting our input for x plus h, and we're going to subtract it to the original function. See, it says what subtracted by f of x, and f of x is negative 2x squared plus x plus 5. Here we have it. Now, because we are subtracting, it's always good to put in our parentheses because we know we're going to have to distribute this negative sign to these three elements that are inside our parentheses. Okay, so when we do that, when we get rid of this parentheses, we're going to distribute this negative sign. So a negative times a negative 2x squared is going to give us a positive 2x squared. A negative times a positive x is going to give us a negative x. And a negative times a positive 5 is going to give us a negative 5. Okay, so then let's simplify. We have a negative 2x squared here, and we have a positive 2x squared. So a negative 2x squared plus a positive 2x squared, we're going to get 0. Now, we have a minus a negative 4xh, but we don't have any other elements that have an xh in them. So that one stays alone. Okay. Then we have a negative 2h squared. We don't have any other elements that have an h squared with them. So again, that one also stays untouched. Then we have a positive x and we have a negative x. So a positive x plus a negative x is going to be 0, so they cancel out. Now then we have an h. We don't have any other elements that have an h, so the h stays untouched. Then we have a positive 5 and a negative 5. So a positive 5 minus or a positive 5 plus a negative 5 is going to give us 0 again. So that one canceled out. So we're left with this equation. Negative 4xh minus 2h squared plus h divided by h. Now, what I like to do is, since all of the three elements on the top have an h, I like to factor out that h. So when I factor out that h, it's going to give me h times the negative 4x minus 2h plus 1. And I do this because this now will allow me to see that this h can be divided by this single h. So h divided by h is going to give me 1. And 1 times anything is just going to result in the original equation. So the answer for this difference quotient, negative 2x squared plus x plus 5, is going to be this. Okay, negative 4x minus 2h plus 1. Any questions on solving a difference quotient problem? So, does anybody have any questions on functions? Like us to go back through any review, go back?
Albert?
Yes, students, this difference quotient is very crucial for Math 1314, for Math 1324, and for Calculus 1. If you guys struggle here, guys, I mean, say that you're going for math engineering, even accounting and business, because you're going to be seeing some, the difference quotient function. This is, like I said, this is crucial. You have to know this stuff because this is, the definition of the derivative, part. So this is crucial, and some students actually get to those courses and they have a hard time understanding because they didn't get it here at this stage. So it's very important for you guys to know exactly what you're doing because you are going to see it again if you are going for math, engineering, or even for business. Okay, so just be aware of that.
Okay, so we can try another one of those. Let me share my screen. Okay, so let's say we have f of x is equal to, I'm just going to make this up, so 3x squared minus 2x plus 8. And we want to find the difference quotient. I will send the slides to your instructors, and you can ask them if they can, hopefully they'll post them for you. Okay, so as Mr. Carizales was saying, you want to make sure you can do this in two parts. So you can evaluate f of x plus h first. Okay. And so anywhere you see an x, we're going to replace it with x plus h. So we would have 3 times x plus h squared minus 2 times x plus h plus 8. And then we want to evaluate or simplify this. So x plus h times x plus h, somebody's writing it for us up there, is going to give us x squared plus 2xh plus h squared. And so we're just multiplying the x times the x times h, and then h squared. So this is going to give us 3 times x squared plus 2xh plus h squared. Then we're going to distribute the negative 2 in here, so we'll get negative 2x minus 2h plus 8. Okay, so let's multiply the 3 inside the parentheses, and so we're at 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 8. And so all of that is equal to f of x plus h. For f of x, that's your second part. So this is your first part, and then your second part is always going to be just the function, the original function, right? So I'm going to write that, let's make it in blue. 3x squared minus 2x plus 8. And so now we can put both parts together, and I'm going to squeeze it up here. So for f of x plus h, we ended up getting all of this stuff. Okay, so I'm going to write it up here. 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 8. And then we're going to have a minus the original function. And I'm going to put parentheses. This is one of the mistakes I see people make, is they forget to put a parentheses. And so they don't distribute that negative all the way across. Okay. So if we distribute the negative, let me just go with black. Then I'm going to kind of make a line here so we can separate this stuff. And so I'm going to put my equal sign. So on the top, we're going to get 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 8. Then we're going to distribute the negative. Negative 3x squared. Negative and negative makes it a positive 2x. And then negative times 8 is a negative 8. And this is all divided by h, which is another mistake. Sometimes people forget to write down their h. So now we want to look, can we cancel any like terms here? So we can cancel 3x squared with negative 3x squared. We can cancel a negative 2x with a positive 2x, and we can cancel positive 8 with a negative 8. And so all we have left now is 6xh plus 3h squared minus 2h divided by h. And then you want to factor, if you look at the numerator, they all have at least one h in common, so we can factor out 1h. If I factor out the h from the 6xh, then I'm left with 6x. And if I factor out 1h from 3h squared, I'm left with 3h. And I factor this 1h out, then I'm left with minus 2. So I can now reduce my h's. And so the difference quotient will now be 6x plus 3h minus 2. So these seem to be kind of long, but if you do them one by steps, then it'll help you to put them back together. So Albert?
Yes, Yvette, what I tell my students, Yvette, here on the step here, okay, Yvette, I'm gonna write here, okay, on the step here, I tell my students, if the term doesn't have an H, it's gotta go somewhere, I mean, it's gotta cancel. So you ask yourself, does this term have an H right here? No, so it's gotta cancel, you see, and it's gonna be over here, I mean, with this one here. Does that have an H? Yes, so that one stays. You see, there it is, right there. Does that have an H? Yes, it stays. Remember, if it doesn't have an H, it's gotta cancel somewhere. Does it have an H? No, it doesn't. So this one cancels right here. Does it have an H? Yes, it stays. Does it have an H? No. So that one has to cancel somewhere. So there it is. You see, so this is how I tell my students to check your work. If the term doesn't have an H, it's gotta cancel somewhere on top there. And that's like a hint that I tell my students if you're doing the work right. Because if you get something here, here with an X, you're doing something wrong. Other terms here, I mean, they have to have an H. Something like an X by itself, you're doing the work wrong. So that's the way I can tell my students to check their work, and they tell me that that's very helpful. So I do want to share that.
Yeah. And the other thing, all of the terms from the f of x will be canceled out. And so if you have any of those left, then you probably forgot a sign or something. So I just wanted to take a few minutes to let you all know, in about a couple of weeks, we are going to be separating the groups into two. So we'll have like the 1324 students, and then we'll have the 1314 students. And so what's going to happen is you would come into this room, and then we're going to separate. That way we can better serve each of the two classes. And then also there'll be an opportunity for you all to also break out into groups and ask questions as well. And then we're also going to have some tutors who are going to be basically ready to help you. So for example, after the session ends, if you feel like, you know what, I feel like I want to stay a couple of more minutes and ask these questions that I had from my homework, then those tutors will be ready and ready to help you. And so another thing I'm going to do is I'll probably let your instructors know ahead of time if there's a question like on a homework that you want for us to kind of cover, then they'll provide you an email where you can send it to us, and then we'll make sure that we try to cover as many of those questions that come in from you guys. Is there any questions? So on February 19th is when we would be separating for the first time. I can't see.
Yes, ma'am.
Okay. Can you email me this flyer when you get a chance?
Yes, ma'am.
Okay. Is there any questions? But we really want to thank you for taking the time from your schedules to join us. And what Mr. Isasi and Mr. Carizales and I are doing is we're looking at the calendars of the topics that are being covered that week. And we're hoping to cover what we think is where students seem to struggle a little bit more. That way we can cover those examples, give you some examples. And but we are open for covering different problems as well.
Does anyone have any more questions on the subjects covered today? If not, I'm going to go ahead and move on here to the OLA guide. But before I do, I would like everyone to please give an emoji round of applause to Ms. Chuka, Mr. Azasi, and Mr. Carazales for all their work and presenting today for the students. So if you could, just give them a smiley, a thumbs up or something, just to let them know that you appreciate them. Thank you, Mr. Azasi. Thank you, Ms. Chuka, and thank you, Mr. Carazales. Mr. Azasi, is there something you wanted to say?
Yes. Hey guys, next week I think we're going to be covering factoring. Hey students, factoring is very crucial for math. And right now I'm teaching pre-cal 2 and also 1325, which is the second part of 1324 for business. And some of the students, they don't know how to factor. And to me, I tell them that they need to know how to factor because it's crucial. Again, especially if you're going for math engineering, you have to know how to factor. So please, guys, do not miss next week. Factoring is very crucial. I believe it's a foundation for the upper level math. If you guys cannot factor, you're going to struggle with your upper level math courses. So please come next week and see how we can help you so you guys can have a firm foundation on factoring. Okay, that's all.
Sure.
So Yvette, there's a comment that they want to go to the last slide again.
Okay, Patricia, I'm going to share the slide, okay?
Yes.
Was it slide 21, I think I saw?
Yes, ma'am.
Oh, 12, slide 12.
It's 12, sorry.
And let me see, is it Peter? Is there a question?
I just want to offer a correction for one of the symbols here. This should have been less than or equal sign.
Let me see, where are you looking at?
I put the blue arrow.
Okay.
Was that it?
Well, this is not quite related, but I'd also like to mention to students that some of you are taking WebAssign. When Mr. Carizales and Ms. Chuka was mentioning the number line for the domain, well, Ms. Chuka already mentioned how to use brackets and parentheses, but WebAssign sometimes uses the number line with the brackets and parentheses instead of closed circle and open circle.
Right.
Okay, that's all. Thank you.
Thank you. Thank you.
Okay, so now I would like to share with you guys our new spring OLA Guide PDF. It's been recently updated and it gives you all of your live links. I'm going to go ahead and post that into the chat for you. Oh, looks like we have a question. As far as having questions about our homework, should we have the exact problem ready on hand before going into tutoring, or should we just ask for some more problem based on the section we're in? Math instructors, do you have a preference?
I mean, my suggestion would be it's okay to show you the problem that you're working on, and then hopefully the tutor is gonna help you by giving you a similar problem. That way you get a chance to work on your actual homework problem, and then while you're working on it, they can check your steps as well to see if you're doing it correct.
Another
But
thing,
I would say I'm working on this problem. Can you help me? And most tutors will give you a similar example, or they see what your mistake is by looking at your work. What are you going to say, Patricia?
I was going to say another nice thing about WebAssign and those kind of programs is they often let you practice another. So even if, let's say, you did it with the tutor and the tutor did that exact problem, if you need more practice, you can do practice another. So if you could please, download this online assistance guide. If you download it to your computer and open it up, it's a PDF document. Everywhere it says click to connect, you can click and it'll take you right to the service you need. And then also, if you look at the top, which is, which I'll point out right here, this is Student Success Online Tutoring. We're open 7 days a week from 7 a.m. to 12 a.m. So just about any time you need help, you can click that link and come see us. The math instructors that presented today, we have Yvette Chuka. She runs the math department tutoring, and she also has her Blackboard room with the hours listed here. Lovely Saturday hours. And then on Sunday, Mr. Azasi runs Sunday numbers. And so if you need help, that's a good resource for you as well. So I strongly recommend you check it out. There's all sorts of different links here. And if you go to the next page here, there's even other resources that may be helpful to you. Another one too is the Tutor Finder. If you need help in a math course or it may be in a different course, you can click the Tutor Finder and you'll be able to check out the tutors that we have for that particular course and when they come on. Next thing I want to share with you is Tohono Passports. So let me go ahead and I'll put that flyer up for you guys. All right, so Tohono Passports, we want to invite you to download it, participate in it with us. So let me put this session's Tohono Passport code into the chat. There we go. So if you're wondering what it is, we'd like you to come and participate in Tohono Passports. Join us here at Tohono Virtual Events each week, and at the end of the session, we'll give you a code, and you can use it towards your own free medallion. If you're already participating, I put the code in the chat, and if not, it's not too late to join. It's still early on in the session and in the semester, and you'll be able to get lots of points. This code will still be good later when you sign up. It's good until midnight tonight, I believe. And also, there's a link on there if you want to know more information before you sign up. You can go to it and find out more. Also, Mr. Azasi's already invited you, but I'll invite you again because it's just that good. We invite you to come to our other Tohono virtual event sessions. So this is next week's sessions. On Wednesday, we're going to have the LibGuide for first-year students, which is actually a good resource for any year students. The LibGuides, if you're not familiar with them, it's a good session to check out. That'll be at Wednesday at 1 o'clock. On Friday, we're going to be having another Careers and Degrees session, and it'll be on the areas of study and the degree types. And then Mr. Azasi was correct. Factory is such an important stepping stone in math, and you will be using it in all your math courses if you are continuing on, and therefore factoring is extremely crucial. We strongly recommend you come to that. And all of these will be in the exact same link as that you came in today. Again, we'd like to thank Ms. Yvette, Mr. Azasi, and Mr. Carrizales for presenting today. We would like to thank you all for being a wonderful audience, and we hope to see you again soon.